In section 6.2, we're looking at adding and subtracting rational expressions. First thing we need to talk about is the least common denominator and how to find it. You want to factor each denominator completely. The LCD is the product of all unique factors, each raised to a power equal to the greatest number of times that the factor appears in any of the factor denominators. So let's go ahead and find the LCD of example number 1. We have x squared minus 4 on the bottom, and we have x minus 2 on the bottom. So the first thing we need to do is factor x squared minus 4. And this is going to factor as x plus 2, x minus 2. And then we have x minus 2 as our other denominator, and we can't do anything with this. So the LCD takes all of the unique factors and then raises it to the highest power that's present in any of the denominators. So that means we need to take x plus 2 we need to take x minus 2 because those are unique. And then looking at the second one, we have x minus 2, but we've already put that down, so we don't need to copy it twice. The last thing we need to do is just check the powers. And so all of these have a power of 1. And so we don't need to change the powers on any of them. And so your LCD is going to be x plus 2 times x minus 2. Let's go ahead and try another one. We want to find the LCD using the denominators of 12xy squared and 15x cubed y. So we need to break this apart. I'm going to use a factor tree so that I can break down 12 as much as possible. So 12 can be broken down into 2 and 6. And 6 can be broken down into 2 and 3. And all of these are prime. So they can't be broken down any further. So when I write 12xy squared, that's like having 2 times 2 times 3 times x times y times y. I just expanded the entire thing. I want to do something similar with 15x cubed y. So breaking down 15, that's 3 and 5, and both of those are prime, so I can't break them down any further. So we have 3 times 5 times x times x times x times y. So now we need to take all of the unique factors. I'm going to rewrite this just a little bit. For 12xy squared, I'm going to put 2 squared times 3 times x times y squared. So that way it's easier to see the powers. And I'm going to rewrite 15x cubed y as 3 times 5 times x cubed times y. So now we need to look at the unique factors and then take the largest power that's present in the LCD. So 2 is unique, 3 is unique, x is unique, and y is unique. So let's go ahead and write those down first. So we have a 2, we have a 3, we have x, and we have y. Now let's go ahead and look at the other set. We already have 3, so I don't need to write the base down again. Now 5 is unique, so we'll need to add that in. We have x, and we have y. So now that I have all of the unique factors written down, we need to see if I need to adjust the powers. So it's the highest power that's present for that factor in either denominator. So let's look at 2 first. The highest power that's present is the 2 squared. So this needs to be raised to the second power. What about 3? Both of our 3's are raised to the first power, so that one doesn't need to change. When talking about x, we have an x to the first and we have an x cubed. So that means we need to take the x and raise it to the third power. For y, we have a y to the first and a y squared. So we need to bring a square to the y. And then the 5, we only have 1 and it's raised to the first power. So now what we need to do is we need to simplify this LCD. So 2 squared is 4 times 3 times, I'm going to move the 5 up here so we can simplify this a little bit, times x cubed times y squared. And so now we just want to multiply the numbers together. We have 4 times 3, which is 12, and 12 times 5 is 60. So our LCD is 60x cubed y squared. Now to add or subtract rational expressions, first you need to find the LCD of the rational expressions. Once you've done that, you're going to write each rational expression as an equivalent rational expression whose denominator is the LCD that you found in step 1. You'll add or subtract the numerators and then write the result over the common denominator and simplify if possible. So let's look at example number 3. First thing we need to do is we need to have a common denominator, so we need to find the LCD. Well, both of these are as factored as they get, so we need to use both of them in the LCD. So my LCD is going to be 6x times x plus 6. And that's what both of my denominators need to look like. So we're going to rewrite each piece of our addition problem here. We have 4 over x plus 6. And so what piece is missing from the denominator to make it look like the LCD? It's missing the 6x. Now what I do on the bottom, I have to do on the top. We're going to do something similar with the other term. We need to look at what's written on the bottom, which is 6x, and see which piece is missing from the LCD. This time it's the x plus 6. And what I do on the bottom, I have to do on the top. So if I look in the denominator, they both look like the LCD, even if the order is different. As long as they have all the same terms, we can then add or subtract the top together. So let's go ahead and simplify the numerators. In the first one, we have 4 times 6x, which is going to give me 24x, all over my LCD, which is 6x times x plus 6. And then for the second term, we need to distribute the 5 to both pieces. So we end up with 5x plus 30 all over 6x times x plus 6. And now we can just add the numerators and put them over that LCD. So I'm going to combine this into one fraction. We have 24x plus 5x plus 30 on the top, all over my LCD. And now we can combine like terms. We have 24x and 5x we can combine, which gives me 29x plus 30 all over the LCD, which is 6x times x plus 6. Now that you've simplified, you just want to make sure that you can't simplify any further. And so, we can't factor the top any more than what's already written there. So this is going to be your final answer. Let's go ahead and try another one. We have 2 over x squared plus 3x plus 2 minus 4 over x squared plus 4x plus 3. First thing we need to do is we need to factor the denominators, so that way we can find the LCD. So the denominator of the first fraction is going to simplify or factor as x plus 2 times x plus 1. The denominator of the second fraction is going to factor as x plus 3 times x plus 1. And so now that we've done this, we can find our LCD. Our LCD is going to be x plus 1 times x plus 2 times x plus 3. And so that's what we need to make both the denominators look like so that we can combine the tops together. So we have 2 over x plus 2 times x plus 1. But what part of the LCD am I missing? We're missing the x plus 3. And so what I do on the bottom, I have to do on the top. And then we're going to do the same process with the second fraction. We have x plus 3 and x plus 1. And so the piece that I'm missing from the LCD is the x plus 2. And again, what I do to the bottom, I have to do to the top. We're going to need to distribute in both of the numerators. I like to think of this as a -4 and just do it all in one swoop instead of looking at two separate pieces. So in the numerator here, in the first one, we have 2x plus 6. And we can just combine this into one fraction right now. Then we have -4 times x, or -4x, and -4 times 2, which gives me -8. And this entire thing is over our LCD. So now we need to combine like terms. We have a 2x and a -4x. And we have a 6 and a -8. So 2 minus 4 gives me a -2x. And 6 minus 8 gives me a -2. All over my LCD. And then we want to see if we can simplify any further. So on the top, we can actually take out a GCF of -2. If I take out a GCF of -2, I'm left with x plus 1. But I have an x plus 1 on top and an x plus 1 on bottom, so those are going to cancel. And I am left with -2 over x plus 2 times x plus 3. Let's go ahead and try one more. The first thing we need to do is we're going to factor the denominators. So we have 2x plus 1, and the denominator is going to factor as 5x plus 1 times 5x plus 1. And then the second denominator, the only thing we can do is take out a GCF of 5, and we're left with 5x plus 1. Now in the first fraction, we can actually rewrite the denominator as 5x plus 1 squared. And so now we can figure out the LCD. We're going to need the 5. We're also going to need the 5x plus 1, and it's going to be raised to the second power because that's the highest power that's present. So let's go ahead and make the denominators look like the LCD. And so the part that is missing in the first denominator is the 5. And what I do on the bottom, I have to do to the top. Now let's look at the second fraction. We have a 5 and the 5x plus 1, but I need to have a second 5x plus 1, so I'm going to multiply the bottom by 5x plus 1, so it's squared, and then I need to multiply the top by 5x plus 1. And so we're going to need to distribute in the first and second numerator. Again, I like to put my negative with the number, so it's easier to just distribute the negative with the 6. So in the first one, we have 5 times 2x, which is going to give me 10x, and 5 times 1, which is 5. I'm going to combine this into one fraction right now. So negative 6x times 5x is negative 30x squared. And negative 6x times 1 is negative 6x. And this is all over our LCD. Now looking at the top, we need to combine like terms. So we have 10x and negative 6x. And I'm going to go ahead and write this in descending order. So negative 30x squared plus 4x plus 5 all over the LCD. And the last step is to see if we can simplify by factoring the top. And we can't, so we're just going to leave this as it is. And so this is our final answer.